Thanks, Jamie. Welcome, everyone. Great to see such a big turnout. So we're going to give an outlook for the next 3 months. Going to give a bit of background just so you know what we're talking about. I'm Claire Spillman. I'm based in Melbourne. I work at the Bureau. So Alistair and I have been working in this space probably almost 15 years now with various different sectors in the marine space. So over to Alistair, if you want to introduce yourself, and then I'll drive the slides from here.
Yeah, thank you, Claire. Yep, my name's Alistair Hobday, and welcome to this seafood climate briefing. We'll cover both fisheries and aquaculture aspects. It will only be marine aspects, though. So for those of you dealing with freshwater fisheries or aquaculture, we might look at tuning things in future briefings, but this will be marine coverage. Thanks, Claire. So we hear a lot about climate change. And we're paying a lot of attention to the long-term future. In general, we're expecting the ocean to warm, which is this dotted line here. But on top of that, you know that we have great variability from year to year. So the lower right plot reminds you that in Australia, we have what are called global warming hotspots. Eastern and Western Australia are both warming faster than the global average. And on top of that, as indicated in the top left figure, we have things like marine heat waves or cold spells, or deoxygenation events that give us great variability. And so as managers, researchers, policymakers, business owners for seafood, we've got to navigate both this long-term trend as well as the variability that we're seeing. The kinds of people we hope would join us today in all phases of this schematic here, where we're talking about today is about some of the climate risks on the left-hand side. They flow through to things in green. So temperature can lead to all these changes in the physical environment. There are operational impacts as a result of that, some positive, some negative, but in general, we see change. And so our briefing today is to help you think about the change that's upcoming, because by the time you're at the fourth wedge here, the business and community impacts, that change impacts on how we do management, how we do business, how we do policy over the coming summer. And not just to say that we have some attention on marine heat waves at the moment, and that's because they're the most dramatic signal of short-term change in the ocean. So this long-term warming is compounded by these rapid warming events. In Northern Australia in 2016, there was very dramatic warming on the Great Barrier Reef that heralded 3 or 4 bleaching events in a row. In 2015, the east coast of Australia was exposed to the largest and longest marine heat wave in this region ever recorded. And so marine heat waves are one thing to pay attention to. And the left-hand schematic just reminds you that as cyclones do, marine heat waves can be classed as category 1, 2, 3, or 4, depending on the particular strength of the event. If we're making a forecast around something like a marine heat wave, you've got some time if we can provide a forecast. And so in this case, this is a schematic that shows a marine heat wave over time. The y-axis is temperature and the x-axis is time through the year. The very highest peak of the marine heat wave is where conditions might be worst. If you can survive that high temperature extreme, then you're just in a coping window until you have a recovery time after that marine heat wave has ended. If a marine heat wave has started, then you're just reacting. And so as managers or business owners, we're reacting to that increased temperature that we're seeing. But a forecast can give you this period of time called a preparation window. And through the work of Claire and I and others, we are now estimating we can give you a preparation window of around 3 months to get some early warning that we might be seeing extreme events. And I've got to say, a preparation window of 3 months is pretty amazing. Mostly you're looking at the 3-day or the 7-day weather forecast in your own lives. We're talking about giving information about the ocean months ahead of time. And that in Australia, we're really on the cutting edge of being able to do this. We're seriously world leading this work at the moment. Our work builds on, as Claire said, nearly 2 decades worth of work with industry and aquaculture, fisheries and aquaculture industries around Australia. And these studies here are to, I suppose, demonstrate to some of you who don't know Claire and I that we have a long history of working with different industries and have a good sense of how the environment does influence your performance in particular parts. And so we've got examples of where the environmental change impacts on aquaculture production, on distribution of East Coast species, on habitat quality around Northern Australia with heat waves and mangroves. And so the kind of environmental information that we're talking about today is only a first step, but we do have experience with helping that translation to the decision making that necessarily follows. So with that framing, let's go through to some of the current ocean conditions that we're presented with. And if you've been following Twitter or LinkedIn, it'll be very clear to you that world temperatures this year are causing dramatic warming. So the plot on the left shows what's called a climatology, and that says for each day of the year, what have been the typical temperature conditions. And the heavy black line is where we're tracking at the moment. And so in the ocean, we're seeing the warmest, the global ocean is at its warmest temperature that has ever been recorded. On the right-hand side, the same is true for the planet as a whole. So at temperatures measured 2 meters above the ocean surface everywhere, land and sea, we're again warming up very rapidly. The Atlantic Ocean is the one that is warming most rapidly of all, and that's giving us a lot of attention to this phenomenon. So this is the framing around why we think a situational briefing at this time is really important for Australia.
Thanks, Alistair. So this is information more specific to the Australian region. So the plot on the left just gives an idea of temperatures around Australia as an average for your sea surface over the last 120 odd years. So you can see the last 20 years have been warmer than all the years preceding that. And this is just for May. So this is hot off, well, pardon the pun, hot off the press. The June values will be out in the next week or two. So we're sitting around here. So if you look across, we're in the top 10 warmest Mays that have been recorded. If we then look around Australia, those warm temperatures there on average are coming a lot from what's going on in the Coral Sea down the east coast of Australia and around Tassie and the Tasman Sea. So what we're showing here is this light orange colour here is saying it's in the top 10% of temperatures ever recorded that are on record, so since 1900 in those locations. West Coast for May this year, pretty average. It's around what we normally expect this time of year, but that heat is across Northern Australia, Coral Sea and around Tassie. So that just gives sort of a spatial picture of that heat. If we bring it a bit closer to today, this is the last week. So this is based on satellite measurements and it is looking at anomalies. So is it warmer or cooler than normal? Anything that is yellow or orange or red is warmer than normal. So this gives us a bit of a picture. This is from last Thursday. You can see there's a lot of heat sitting off New Zealand and also heat sitting around Tassie. So those colours in there are around 1.5 degrees warmer than normal last week. If we then bring that down to, I think this is for yesterday or the day before, this is from a marine heatwave tracker. So the definition we're using of a marine heatwave is that top 10%. So when temperatures are in there, they're classed as extreme. And if you get it experience those temperatures at a location for a number of days in a row, that's classed as a marine heatwave. So this is what the global picture was for marine heatwaves a couple of days ago. You can see New Zealand's lighting up and there's also moderate marine heatwave around Tassie. The UK is really cooking, so I'm glad I'm not talking to anyone from there today because I'd be asking lots of questions. So that is off the scale. That's extreme. All right, so that's kind of the current picture at the moment. So stepping forward into the seasonal outlook. So this seasonal model is what is run at the Bureau. All our seasonal outlooks, when I talk seasonal, I'm talking months, up to 6 months into the future. It all comes from the one model. So if we're predicting, heavy rain here in the next month, that is the same model that is telling us whether it's going to be warmer or cooler than normal in the ocean. So this little animation here is the actual sea surface temperatures on a daily basis, just coming out of the model to give you an idea. So Access S2 is the model that we use. So basically it is a big computer model. We slice the ocean into a 3D grid. So you've got grids across in the horizontal and then down to the ocean floor. It's based on physics. So events that have never happened before can be forecast, Whereas if it's a statistical model, that's based on what we've seen in the past. And as Alistair demonstrated, we're seeing unprecedented events, and we can't just expect what we've seen before with climate change. So this model includes things like winds, rain, currents, sea ice, radiation, clouds. It's the whole climate system, and it uses all our latest observations that we've got. So some of those observations I just showed you, where we were saying, it's warm last week, warm a few days ago, all of that information goes into the model to give it the best idea of what the current picture of the globe is, and then we run the model forward in time. So one of the things we do with the model is we run 40 years of hindcast. So what we mean is we run it retrospectively. So we run it from the early 80s up until up to 2018, and we have a look at how well the model did, forecasting those past events. And that gives an idea of how reliable the model is, so that when you're looking at your forecast, you look at your forecast for the next few months, and then you look at how well did it predict these kind of conditions at this time of year in my location over the past 40 years. Gives you an idea of how well the model does. So this is a global outlook. So this is for the next 3 months, so July through to September. And unless you've been sitting under a rock, you would have heard people talking about the potential for an El Nino this summer. So this is what you can see here. This, we call it a warm tongue coming across the Eastern Pacific. This is your typical signature for an El Nino event. This box here is the Nino 3-4 index, and I'll show you in the next plot. We've also got stuff happening in the Indian Ocean if you're an operator on the west coast of Australia. This is where we'll talk about the Indian Ocean dipole. So that dipole is using information in these two boxes, so Western and Eastern Indian Ocean, and Nino 3-4 is an indicator of El Nino, La Nina. Again, showing that heat off Tassie around New Zealand and some heat in the Coral Sea. So if we step forward now into the ENSO outlook, so the Bureau's current official, status, ENSO status, is that we're on alert. So that means in the past, when we have reached this stage, there's a 70% chance that an El Nino will develop this year. So we will start, if it develops, that will start to happen in the next few months, and our models will have more and more certainty around the event happening. The reason the Bureau hasn't come out and said it is an El Nino, so NOAA, which is equivalent in the US, has said it's an El Nino going on their indicators, that what's happening in the ocean is just one of the things we look at. So we also look at the clouds and wind and see what they're doing. And the ocean has definitely got the right El Nino pattern, but the cloud and wind and pressure distributions that the Bureau looks at haven't quite settled into what we would consider an El Nino pattern. So that's why we're at alert, saying it's likely to happen, or at least there's a 70% chance it's going to happen, but it's not locked in yet. So this plot here is from Access S2 from the model. So that is that box that was sitting in the middle of the Pacific. This is the average of what's going on at the surface. These black lines here is what we've observed. This grey spaghetti here is from Access S2, which is the model. So what we do is we run the model 100 times because we don't have a perfect picture of what the ocean looks like. We've got lots of observations, but we don't have a perfect coverage. So there is error in there. We run the model lots of times and have a look at what are all the possibilities based on the information we have today. This green line is the average. And as you can see, the Bureau's model is really gunning for an El Nino. So all our grey spaghetti, all our forecasts are sitting in this pink area for the Nino 3-4 index, which is the ocean indicator. If we look over here on the right, so what the Bureau does, we run our own model, but then we also make sure we're not talking out of school and that we're in line with what other institutes around the world are talking. So these models, these little plots just down the side are just showing what the other models around the world are saying. Ours is the top grey line, and so we've got the forecast for July, which equates to that dot there, August and September. So we've got models from Canada, Europe, the UK and the US. They're all indicating that an El Nino will develop. the strength of that El Nino is not, I guess, necessarily clear yet. The Bureau's model is indicating it's going to be a pretty strong one, whereas other models are indicating one will happen, but not to the same extent. So if we were talking, when we're talking to stakeholders and customers in June, we would say, be alert, keep an eye on the forecast. It will become clear as that if and when that El Nino will develop, and then we'll have a better idea as well of the strength that as we approach through to the end of the year. The other factor is the IOD. So that's the Indian Ocean Dipole. Those were the two boxes in the Indian Ocean. So we have a look at the gradient. So if a dipole means it's hot on one side, cold on the other. All the models are indicating it's going to be a positive IOD this year. If we step back one plot, that basically means it's warm over India and near Africa, and cool over near Indonesia. So basically what that means, the take-home message from that is, the rainfall happens where the ocean is warm, there's lots of convection, doesn't happen over this side. So when you get an El Nino and an IOD, that means we're going to have a very dry season. The IOD exacerbates what's happening with an El Nino. Which brings me to the rainfall outlook. So I know Alistair said we're talking the marine space, but for those who are considering what's going on right on the fringe in terms of rainfall and air temperature, these two plots, so all of these plots that you're looking at, you can get on the Bureau webpage. So they're all there. This one here on the left, so this is for July to September, is showing the chance of above median. So about above what you'd expect this time of year. So it's showing is a pretty low chance that we're going to exceed the median for this upcoming season. The more interesting one is on the right. So this is saying, what is our chance of being the lowest 20% of rainfall for this season? It's up to 2 times greater chance of there being low rainfall in Queensland, Victoria, and particularly WA. So that is a result of that El Nino signal that we're getting in the model, as well as a positive IOD. So those combine to reduce the rainfall across the most of Australia. The other piece of information that goes with that, but if you're right inshore, you're going to be interested in this, is air temperature. So this again is for July through to September. This one looks pretty dramatic here on the left. It's basically saying there's a very, very high likelihood we're going to exceed the median for air temperature during the day, which means it's going to be hotter than normal. If we look on the right, this is the chance of it being in that top 20% again, so really hot. And again, WA is lighting up. High probability it's going to be in the top 20%. It's also pretty warm down around Victoria and Tassie. Based on today's temperature in Melbourne, I'm kind of okay with that, but that's just based on me here. So warm and dry is the message coming out of the model for the next 3 months. All right, let's get in the water now. So this is the sea surface temperature, so the top meter of the ocean. What's it doing for the next 2 fortnights? All coming out of the same model. So what you can see here on the left is from a couple of days ago till the start of July. And then the one on the right is the first 2 weeks of July. So again, it's getting to be a bit of a pattern. Coral seas lighting up all down through the Great Barrier Reef and as well as offshore, up towards the Torres Strait in Indonesia. So we're looking at temperatures around 1 to 1.5 degrees normal. Sorry, 1 to 1.5 degrees warmer than what you'd expect for this time of year. We've also got the same sort of patterns happening down here off the west coast of Tassie and into the Tasman Sea. But this time of year is actually quite cool off the northwest shelf and down the WA coast. That pattern persists for the next fortnight as well. So again, Coral Sea warm, some of that heat's coming across northern Australia, around Tassie, Tasman Sea, and those cool conditions are set to continue down the west coast. The caveat with that, these green plots, is how good does the model do for these fortnights based on the last 40 years of forecasts? Anywhere that's green, the model does a pretty good job. We're happy with that. Anywhere that's white, the model does not do a good job. historically. That tends to happen in areas where there's lots of eddies, where there's lots of dynamics in the oceans changing rapidly. For a seasonal forecast model that's trying to predict 6 months ahead, it's really hard to catch those local changes that are happening rapidly on weather timescales. The model doesn't do a good job of that. So the take-home message is that the forecasts for the next fortnights are pretty good. You can be pretty confident in them. There's not a lot of skill or accuracy here off New South Wales in the East Australian current. Lots of eddies happening there. Same story here offshore in WA. All right, next 3 months. Same patterns happening, Coral Sea. So this is July on the left, August in the middle, September on the right. And these are anomalies again. So warmer or cooler than what you'd expect for July, what you'd expect in August, and what you'd expect in September. So we're looking at anomalies around 1 degree warmer than normal, up to maybe 1.5 degrees, all the way down the east coast of Queensland or down the coast of Queensland. East coast of Tassie is up around 2.5 degrees, and there's also warming on the west coast as well. WA and through the Bight around South Australia are looking pretty normal. Anywhere that's sort of white is around what you'd expect for this time of year. Stepping through to August, that heat is now moving all the way down the coast. So we're warming up on the New South Wales coast through Bass Strait and around to the south of Tassie. And that pattern pretty much hangs around through to September as well. We're seeing Coral Sea, New South Wales, Victorian coast and around Tassie. Bearing in mind, you've got to look at the accuracy of the model. So in July, the accuracy of the model decreases the further out we're trying to forecast. So it's always better for the shorter lead time. So if we're only forecasting a month out, we're going to have more confidence in that than if we're trying to forecast 6 months out. So forecast looks pretty good. Everywhere that's green or yellow, we're happy with that. We step into August and September, and you can see there's a bit of uncertainty around what's going on offshore. For WA and South Australia. And also that same patch off New South Wales shows up. That's because there's lots going on there. And same for September. But we've got good confidence around the northern coast of Australia, so northern WA, through the Bight, through the Gulf, sorry, and down Queensland and also around Tassie as well. The other thing to bear in mind that the model has more skill or more accuracy when there's a really big driver happening. Something really big is happening in the climate system, like an El Nino or a La Nina event, we usually have more confidence in what our forecasts are showing us because that is what's driving, that's the main signal that's influencing the ocean around Australia. Okay. So the next step, so this is moving into marine heat waves. So into the extremes is that top 10% of your ocean temperatures at your location based on history. So this is showing same 3 months, July, August and September. So if you remember from the ENSO plot or the plot showing El Nino, that grey spaghetti, that's our 100 model forecast. So what we do is we look at each grid cell, each spot, and say how many of the model runs are saying it's going to be a marine heat wave. Gives you an idea of how certain the model is that condition's going to happen. Anywhere that's this dark green colour, we got 80 to 100% of our forecasts are saying you are going to exceed that 90th percentile. So you're going to be in the top 10%. You can see that Coral Sea through the just offshore probably of the reef down here and starting to extend down into northern New South Wales. Tassie again lighting up west coast and around offshore on the east coast. Not much happening anywhere else, so low probability that you're going to be marine heat wave conditions. You still might be warmer than normal, but you're not hitting that high threshold for most of WA and through South Australia and the Bight. Similar pattern for August and September. You can start to see that a few of the forecasts are indicating through the Bight in September that they're going to start warming up, hit that threshold, 30 to 40%, but that 80 to 100% is still happening here in the Coral Sea. And now it's moved down to New South Wales, Victorian coast and Tassie. So taking that information, so that's what all the model forecasts are telling us, We then take it and put it into a marine heatwave forecast. So what is the model predicting at each location? So anywhere that is yellow, it's a moderate marine heatwave. That's the first category. You've just tipped over the threshold. And for the most part, for the next 3 months, that's what we're indicating. That's still really warm, to be clear, but we're not up here on these extreme temperatures like we saw off the coast of the UK in the earlier plots. So moderate marine heat wave for pretty much all the Coral Sea for July, August and September, and right up to Torres Strait, and again, Tassie, East and West Coast, and Victorian, South Coast and Bass Strait for August and September. All right, over to Alistair. So that was the outlook. I will happy to take all the questions after we finished. Go, Alistair.
Beauty. So that suggests we're going to start to accumulate heat in the ocean and affecting biology by about September. So that's just the onset of spring. And if we keep going that way, we will have had a very early start to warming. And that's why managers of the Great Barrier Reef will be concerned by this. So let's have a think then. At this stage of the seasonal discussion, what can we do about it? And I think the role of many of us on this call is to be able to use this information about the future. But the ability to do anything about it depends on the particular system. And so the regulatory environment will restrict how people respond to forecasts like this. The obvious example we've been using is that if fisheries have static boundaries, that regulatory environment may prevent fishers from catching in different locations. For aquaculture, if you're not able to move to your fallowed lease sites, which might be in cooler parts of the lease area, that's again a regulatory restriction that might prevent this good industry agility. If a fishery or an aquaculture business can deliver its product earlier in the season, then that's an adjustment based on market forces. But if you're going to hit the Christmas market, no matter what happens to the environment, that would be less agility for that group than one that could harvest at different times. And we could work our way around this, but I think I'll just say that there are a range of things that the people on this call can do to make sure that those who need to use the forecast and respond are able to do so. We're telling you a little bit about number 7. There is a really strong signal coming in some parts of Australia, and so that should start to better prepare people in those regions for this possible future. The West Coast, though, is not having very strong impacts at the moment or projected impacts, so I suggest that there's not going to be a need for much agility on the West Coast at the moment. Final one, please, Claire. And so what do you think? What do we think you should do at this time? This is a timeline leading up to from June. Our first briefing today, we're predicting some general events around Australia by September. By the time we meet next in August, we will actually have, I'd say, more reliable forecasts. And at that point, you would be more certain about the actions that you're going to do. Later, by about November, we may actually be inside some of these events. And so there'll be a different responses at that time as there will be during the recovery phase. So depending what phase you're in, there'll be different things that we would suggest. What would I do today? I'd start to look at, if I'm a researcher, getting baseline data on performance of species in some of these areas that we are predicting there's going to be events. As operators or managers, you might revisit past marine heatwave effects in the region of interest. If you remember what happened off the east coast of Australia in 2016 heatwave, I'd be having a look at how your industry coped at that particular time. In northeast Australia, the same thing. What did we do the last time we encountered these events? South Australia, you may be entering a kind of a warming that will be a bit of a surprise to operators in that region. So are there past conditions that can help you start to have this conversation? The last 3 things are, again, just have a think about where you'll get vulnerability. Is it going to be in where areas are affected by rainfall or runoff, or in the temperature areas? What species are going to be vulnerable? And we've got plenty of information that has been developed over the past decade or so to identify vulnerable species and habitats. And then particularly for managers and for industry associations, who are going to be the vulnerable aspects of our communities if we experience some of these events this summer? So it's at in an alert sense, we're at a watch and wait sense. Be alert but not alarmed. As we said, we've scheduled future briefings for mid or late August and early December. where we'll have more certainty about some of the things that are coming up over the summer. And depending on the feedback, we may tune those to provide more information on other variables or tackle other aspects of the response options that might be put in place, or even share amongst the jurisdictions how are you handling the different response or the advice to your stakeholder groups.